right, I want to make sure that everybody understands how we can use fossil assemblages to figure out the relative age of rocks. Now, in your lecture, you have this picture, and then in your in-class activity, you have this one, and they're basically the same thing. They just have some different organisms, and along this scale is geologic time with youngest on top, oldest on bottom, youngest on top, oldest on bottom. All right, in your lecture, you learned that if you have an index fossil, you're pretty happy. An index fossil is an organism that lives for a very short period of time, and it's geographically widespread. But what happens if you don't get one? What happens instead? You just get a whole bunch of different animals that actually live for long periods of time. You can still narrow it down. In some cases, you can actually get it as narrow as if you did have an index fossil. So again, pretend like this is a big stack of rocks and it's all fossiliferous, and we are going to study this section right here. So, I park students at different levels and we collect fossils, and let's say I parked you here in the B horizon. All right, so what are you finding in your B horizon? You are finding, this is called a trilobite. Okay, so trilobite. This is called a brachiopod, so brachiopod. Okay, that's a starfish, or what was called a starfish is now called a sea star. Okay, that's a scallop, and I like scallops, and they've been around for a long time. Look how long scallops have been around. All right, and the last thing is ginkgo biloba. Okay, that's that, you take that if you have a bad memory or something, and that has been around longer than the dinosaurs. So basically, the 5 organisms that we're finding, 1, 2, 3, 4, 5, I always check them off, okay? Now, we're going to do what I call the straight edge method. Now, you might say, well, there may be some other organisms that are there. Yeah, but we didn't find them. This is what we found. And what we need to do is we need to lift our straight edge up. So if, like right here at the first Paleozoic period here, the oldest part, because oldest is lowest, what I've got going on is I've got 1, 2 of my species. Okay, I keep lifting. I have 3 of my 5 species. 4 of my 5 species. Finally, I have all 5 of my species. So this is the youngest that this could be, or the oldest, I'm sorry. This is the oldest that this could be. And it can't be any older. You might say, well, why isn't it that old? It can't be that old because ginkgo biloba had not evolved yet. Then all we have to do is, keeping our eyes on our 1, 2, 3, 4, 5 species, lift this up until the first species goes extinct. And over here, my trilobite's about to go extinct. There's where my trilobite went extinct. So I would take this over to my time scale, and I would say that the only place where I would find all 5 of these fossils is in this time frame. Okay. Now let's say that you were instead up here in the A horizon, and what you're finding in the A horizon is, okay, I'm just going to show a different symbol, ginkgo. Okay, some sort of a weird bird, a dinosaur, a maple leaf, and again, a starfish. Okay, so you might say, well, where's the scallop? We didn't find one, so we wouldn't count that. We're just going to count these kind of 5 inner species here. And we're going to do the same thing. We're going to do the straight edge method. Okay, I have the sea star, but I don't have any of the other ones. Okay, keep lifting, keep lifting. Okay, now I've got sea star and ginkgo, but I'm still missing 3 of the 5. Okay, I got my dinosaur, I got my funky chicken. Finally, there's that last organism, maple leaf. It has finally evolved. So this is the oldest that this outcrop can be, because all of the organisms need to coexist. And all I have to do, like I said, is lift this up till the first organism, and in this case 2, go extinct at the same time. And this is the youngest. Remember, it can't be that young because these guys are already extinct. Okay, so what we've done is really narrow it. Now, you guys will be doing the same thing with me naming some organisms and you finding them on here. And what the black line represents is, how long do they live? So sharks evolved sometime in the Devonian, and they're still alive today. So up here, is today, and here's way back in time. Okay, so we always put it like this in geology. We always put the youngest here and the oldest there. Okay, just checking the focus here. All right, well, let's just say that I told you that you had 2 species, and that's all you found were 2 species. And what we want to do is we want to narrow down, when did those 2 species coexist? And we'll just do that same straight edge method. Okay, we just find a piece of paper works fine. Well, it looks like they both evolved around the same time. Phacops and conides, a trilobite and a brachiopod. Okay, and then we're going to draw our straight line. This is the oldest it could be. And then lift this just up until the first organism goes extinct. And what we've done is we have narrowed it down. If you're finding these two species, the only place that they coexist in the geologic timescale is for the Devonian and a little bit of the latest Silurian. Now, I'm just giving you guys this example. You'll be asked to, identify maybe 5 of them and then do that straight edge method to figure out when they all coexisted.